next question, prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Sum of the squares of the sides of a rhombus. If you are not comfortable with the sentence in the question, you draw a rhombus. What's the specialty of a rhombus? All the four sides will be equal, isn't it? And one more specialty is there, if all the four sides are equal, the quadrilateral can be a square also. The diagonals will be perpendicular bisectors. It makes angle 90 degree and also it will be the bisector. So if I am naming the rhombus as A, B, C, D, what is given? Sum of the squares of the sides. Which are the sides? A, B. So sum of the squares of the sides means AB square plus BC square plus CD square plus AD square. Sum of the squares of the sides is equal to sum of the squares of its diagonals. Which are the diagonals? It is AC and BD. Sum of the squares of its diagonals means it is AC square plus BD square. So what we have to do is we have to prove AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. Okay, so what we will do is we will take the intersecting point as O. So since it is a rhombus, it is clear that AC is perpendicular to BD and also the perpendicular bisector. Okay. So now what we are going to do is consider one of the triangle. I am going to consider triangle AOP. Okay, it's a right triangle. If it's a right triangle, we can apply Pythagoras theorem. Hypotenuse square equal to sum of the squares of the other two sides. So we can write AB square is equal to OA square plus OB square. Okay, what about OA? OA is this much length. I already told that the diagonals are perpendicular bisectors. So instead of OA, I can give the value 1 by 2 of AC. It is AO is half of AC. So instead of AO or instead of OA, we can give AC by 2, the whole square, plus instead of OB, what we can give? OB will be half of BD, isn't it? We can write OA equal to OC and OB equal to OD. Why? Because they are perpendicular bisectors of the rhombus. Diagonals are perpendicular bisectors of the rhombus. So instead of OB, I can give the value BD divided by 2. Okay, so this is equal to BD divided by 2, the whole square. So this is AC square by 4 plus BD square by 4. If I take the LCM, the denominator is common 4. So AC square plus BD square. The left side is AB square. Okay, if I take this 4 to the left side, what I can write? 4AB square is equal to AC square plus BD square. Instead of writing 4AB square, I can write as AB square plus AB square plus AB square plus AB square is equal to AC square plus BD square. And since it is a rhombus, we know that each and every side means all the four sides are equal. That means AB is equal to BC is equal to CD is equal to AD. Okay, so instead of 1 AB, we can give the value BC. Instead of the third AB, we can give the value CD. And for the last one, all these four sides are equal. So instead of the last one, we can give the value AD square is equal to AC square plus BD square. So this was what we have to prove. Sum of the squares of the sides is equal to sum of the squares of the diagonals. So we proved that sum of the squares of the sides is equal to sum of the squares of its diagonals. Okay, we just applied the property of rhombus.